Hey everyone, welcome back. So today we're diving into something pretty revolutionary, an idea that's totally changing how AI works. We're talking about teaching AI to get smarter without it ever having to peek at our personal info. Yep, this is our explainer on federated learning.
So let's just kick things off with a huge question, right? We all want smarter apps, better AI, the whole 9 yards, but what about our privacy? Is it even possible for an AI to learn from all of us together without ever looking at our private individual data? I mean, it sounds kind of impossible, doesn't it? Well, that is the exact problem federated learning was built to solve.
All right, so to really get this, we first need to understand the basic conflict that's been at the heart of machine learning for years. It's what you might call the AI data dilemma.
So think about it. Traditionally, for an AI to get good at, well, anything, predicting your next word, spotting a disease in a scan, it needed a ton of data, an absolute mountain of examples. And the old way of doing things was pretty straightforward. Just collect all that data from everyone everywhere and pile it all up on one giant central server to train the AI.
So in the old model, our data has to travel to the model. But you can probably see the problem here, right? Shoving everyone's private information into one huge digital basket, well, that's just creating a massive, juicy target for data breaches. And it brings up some serious privacy issues. That was the fundamental trade-off we always had to make. You could have smarter AI or you could have privacy. It felt like you couldn't have both.
But what if that's a false choice? What if we could have both? This is where this whole new way of thinking comes in, and it completely flips that old model on its head. It's a new way to learn without having to share.
And that brings us to federated learning. So what is it? At its core, it's a machine learning technique that lets a shared AI model get trained by tons of different people or devices without any of them ever needing to send their raw, sensitive data anywhere. The data just stays put. It stays on your device.
I really think this quote nails the feeling of it. It's all about collaborative learning, but on a massive scale. Everyone gets to contribute to making the AI smarter for everybody, but nobody has to give up their private info to do it. Your phone, a hospital, your bank, they can all help out, and privacy stays intact.
So if the data isn't all going to one central place, what happens instead? Well, the big idea here, the real shift, is this. Instead of collecting everyone's personal notebooks to write a master study guide, you send a blank study guide template out to every student. They fill it in with what they know, using their own notes, and then they only send back the updates or the improvements to the template, not their original notes. See the difference?
Okay, that sounds great in theory, right? But how does that actually work? Let's get into the nuts and bolts of the process. It's actually a pretty elegant little cycle that just keeps repeating.
It all breaks down into 5 key steps. First step, distribution. A central server sends out a basic starting AI model to all the devices. Step 2, local training. Each device takes that model and trains it using only its own local data. And remember, that data never ever leaves the device. Then step 3 is update reporting. The devices don't send back the data, they just send back the small learned updates, the new lessons. Step 4, aggregation. The server takes all those little updates from everyone and averages them together to improve the main global model. And finally, step 5, iteration. The server sends that newly improved model back out to all the devices, and the whole cycle starts all over again.
So this whole system really just has 3 main parts. You've got the clients, that could be your phone, a hospital, a bank, whoever has the data. Then there's the central server, which is like the orchestra conductor. It organizes the whole process, but, and this is key, it never actually sees the raw data. And finally, you have the aggregation algorithm. That's basically the mathematical recipe the server uses to mix all those updates together to create a smarter model.
Okay, so now we know how it works. But where is this stuff actually being used? This isn't some futuristic lab experiment. It's already out there, in the real world, making a difference right now.
And the applications are, well, they're everywhere. Seriously. If you use the keyboard on your phone, like Google's Gboard, you've used federated learning. It's how it predicts the next word you're going to type, learning from millions of users without ever reading your private messages. Or think about healthcare. Hospitals can work together to train amazing diagnostic AIs on patient data without ever breaking patient privacy. Self-driving cars? Yep, the whole fleet can learn from each other's driving experiences to get safer. Even banks are using it to build better fraud detection models together, all while their customer data stays safely locked away.
And it turns out there are a couple of different flavors of this. The most common one is called horizontal federated learning. A good way to think about this is a bunch of hospitals. They all have the same kind of data,
patient records, but for different people. They can team up to train a model. But then there's vertical federated learning, which is a little different. Imagine a bank and a big retail store want to work together. They have different kinds of data, right? Financial data versus shopping data, but they might have a lot of the same customers. Vertical FL lets them combine their different perspectives to build a much richer picture, again, without ever directly sharing who bought what or who has what in their bank account.
Now, of course, no technology is perfect, right? It's not a magic bullet. Federated learning has its own set of unique challenges that people are working hard to solve. So let's take a look at some of those hurdles and what the future might hold.
So what are the roadblocks? Well, first off, everyone's data is different. The data on your phone is not the same as the data on mine. Researchers have a fancy term for this, non-IID, but it basically means that this variety can make it harder for the model to learn one consistent thing. Another issue is just the sheer amount of communication needed. All those updates going back and forth can be a lot, especially for devices on shaky networks. And finally, while it's built for privacy, it's not totally invincible. There's still clever, advanced attacks that could try to compromise the system. These are the big puzzles the community is trying to solve right now.
So where's this all going? Well, the next big step is to become even more decentralized. Right now, a lot of these systems still have that one central server calling the shots, and that can be a weakness. The real future might be in true peer-to-peer systems, where devices can just talk and learn directly from each other, with no central boss. That would make the whole network stronger and even more private.
And that really brings us to the big picture here. Federated learning, it isn't just a clever bit of tech. It's a fundamental shift in how we think about data, privacy, and working together. So I'll just leave you with this one question to think about. What new possibilities could we unlock? What scientific breakthroughs? What amazing new services? What solutions to really big global problems could we find if we could all collaborate on a global scale without ever compromising our privacy? Something to think about.